Hello, welcome to Zigmatech Learning Hub. I'll be your instructor for geography. For this class, we are going to be taking our exercises from the Examguide app. If you don't have the application already installed on your device, I will want you to download the app in order to follow along in this class. Examguide is a leading educational app that helps students prepare adequately for various exams like UTME, post-UTME, WAEC, GCE, KCPE, IJMB, JUPEB, Carbopedia, BECE, JSCE, NCEE, NECO, etc. You can download the app from www.examguide.com or Google Play Store. Please subscribe to our channel and turn on the notification bell to be updated on new videos. Ready for today's class? Okay, let's get started. So, in today's lesson, we'll be looking at a topic called mountains. And we are going to be looking at the meaning of landforms, which includes mountain and plateaus. Then we'll also look at the major types of mountains we have and the different characteristics of each of these mountains. And then also we are going to look at the processes involved in the formation of these mountains, and then we'll look at the importance and also the disadvantages of mountains to man. So, before we commence, if you look around your environment, you will discover that we have places that are very low in terms of height from the sea level and places that are very high. And one of these high places or high feature is actually a mountain or a plateau. So all of these things are actually referred to as landforms, be it the lowland, be it the mountain, be it the plateau, provided they are just physical structures that we see in our environment. So what are landforms? A landform is simply any feature of the Earth's surface that has a recognized shape. Any feature that you see in your external environment with a recognizable shape is simply referred to as a landform. And examples of landform include the mountains, the plateaus, the hills, the valleys, the lowlands, the waterfalls, and the deltas. So these are the different landforms that we can see in our physical environment. Now let's look at one of the landform we have for today, which is called mountain. If you've watched, seen foreign movies, or you've seen movies shot in, countries where we have highlands, I guess you've probably seen what a mountain, looks like. Now, a mountain is simply an imposing or impressive mass of rock that rises steeply from the ground surface to a greater height, and the height is usually at a range of 600 meters and above. And the top of the mountain is actually called a peak, or you can actually call it the zenith. And the lower part of the mountain is referred to as a valley. Now, let's look at the different mountains we have in the world. And not just different mountains we have, but the tallest mountains in the world. In Africa, the tallest mountain is Mountain Kilimanjaro. Then in Europe, we have Mountain Elbrus as the tallest mountain. Then in North America, we have Mountain Denali. In South America, we have Mountain Aconcagua. In Asia, we have Mountain Everest, which is in the Himalayas and is the tallest amongst all the mountains of the world. Then in Antarctica, we have Mountain Vinson Massif. Then if you go to Australia, the tallest mountain in that continent is Mountain Koskiuzoku. And also we have, in Oceania, we have the Jaya Peak, or you can call it Mans Carstenses. So these are some of the mountains that are probably the tallest we have in the world. So let's look at it in terms of a pictorial representation. Now, if you look at the map of the world as we have here, you will see that Mountain Elbrus is, found just below the Russian territory, and it has an elevation of 5,642 meters, or 18,000 feet from the sea level. Then you come down to the eastern part of Africa, which is in Tanzania. We have Mountain Kilimanjaro right there, and it has a height of about 19,000 feet, or 5,895 meters high. Then in the Himalayas in Asia, where we have Mountain Everest in Nepal, China, it has an elevation of 29,000 feet, making it the highest, and also in terms of meters, it's over 8,800 meters high. Then you go to the North America, we have Denali right at the extreme north of America, which is in Alaska in USA, and the elevation of that mountain is about 6,194 meters high, or 20,000 feet, and above. Then in Antarctica, we have the Vinson Massif, which is 16,000 feet high, and in South America, Aconcagua has an elevation of about 22,000 feet from the sea level. So these are some of the mountains, the tallest mountains we have in the world. So we can as well look at some important mountains, that are found in some mountain ranges in the world. And previously we've looked at the Mountain Everest, which is in the Himalayas. Himalayas consist of Everest and few other smaller mountains. Then if you go to South America, we have the Andes Mountain, which is a popular mountain we are going to look at in the next slides. And then we also have the Alps Mountain in Europe, which is found in the ranges of Mountain Black, and it has a height of 1,200 meters. Then we have the Rocky Mountain in North America. Rocky Mountain is actually found in mountain ranges of Mountain Elbert, and it has a height of 4,800 meters. Then in Africa, and Morocco to be precise, we have the Atlas Mountain, which is somewhere in Jebel Toubkal, and it has a height of 2,410 meters. Then if you go to Australia, there is the Great Dividing Range, which is 3,700 meters in elevation. And also in Russia, we have the Ural Mountain, which is about 2,400 meters high. So these are some of the mountains we have. And let's look at the types of mountains, So we basically have 4 types of mountains. The first type of mountain is called the fold mountain. The second type of mountain is called the block mountain. Then we have the residual mountain and the volcanic mountain. So let's look at each of these mountains one after the other and look at their mode of formations and their examples. So we start with the fold mountain. As we all know, when we say fold, we're actually talking about something being bent or squeezed, or something that is possibly wrinkled. Now, a fold mountain is not far away from that ideology. Now, a fold mountain is simply an upland or a highland area that is formed as a result of the wrinkling and buckling of the lithosphere or the earth crust. And it is actually caused by the movement, or will I say the horizontal movement within the earth crust. So as we have here, this is just a typical example of what a fold mountain looks like. It's it consists of synclines and anticlines, causing it to have a series of crest and trough. So we look at how fold mountains are formed. Now, like I previously said, that fold mounting is actually caused as a result of horizontal forces, going on within the earth crust or the lithosphere. Now, a fold mountain is actually formed when this movement, or this horizontal movement, to be precise, develops in the earth crust. And when these movements actually happen or occur, there is actually a build-up of stress, in the earth crust. And as a result of that stress, we begin to have what we call compression and tensional forces acting on the tectonic plates of the earth crust, causing the horizontal rock layers to squeeze or crumble or wrinkle downwards and upwards. Now, when it's wrinkling upwards, we call it an anticline. But when it wrinkles downward, we call it a syncline. And also, anticlines are seen as crests, while the synclines are seen as the trough. So, that is basically how the fold mountains are formed. So, let's look at what an anticline and a syncline looks like. So, the thing is this: when these compressional forces, act on the earth crust, we begin to see the fold like this. As you can see, we have layers of rock that is being affected by these horizontal forces. Now we have here the syncline, and we have here the anticline. The anticline, like I said, is the up fold. The anticline is the up fold, while the syncline is seen as the downward fold or the trough. So this is basically how the fold mountain looks like. So we have different types of fold. We have number one, we have the simple fold, and it's called a simple fold when the forces or the horizontal compression does not cause the mountains to be pushed too far, or cause the earth crust to be pushed too far. Now, they are called simple fold, but when we say the fold is an overfold, it is definitely at the point where the anticlines are being extended to a further distance. So a stretch of the anticline or the upfold will actually result in what we call an overfold. Then the fold is said to be recumbent when the overfold stretches further, or when the the anticline is pushed further and further. So that type of fold is called a recumbent fold. Then we have the next type of fold, which is known as the asymmetrical fold. And the asymmetrical fold occurs when one limb or one edge of the fold is deeper or steeper than the other. So when one fold slides in a very steep direction, while the other fold or the other limb of the fold is actually gentle, such appearance is called an asymmetrical fold, because one fold is steeper, the other fold is not steep. So now this asymmetrical fold is actually as a result of the inequality in the compressional force on the different layers of the rock. So that's why you see one fold being longer or steeper than the other. So the next type of fold is what we call the symmetrical fold. Now the symmetrical fold is just the opposite of the asymmetrical fold. In the symmetrical fold, you see that every limb of the fold is actually uniform. They all have the same uniformity. So when we see uniformity in the syncline and in the anticline, we call such a fold mountain a symmetrically type of fold mountain. Then we have the last type of fold mountain, which is referred to as overthrust fold. Now, in overthrust fold, the upper limb of the mountain or the rock is actually pushed further along the horizontal plane so that the upper portion of the fold slides over the what? The lower part of the fold. Now, the part of the fold that is overriding the the lower part of the fold is actually called a nap. So these are the types of fold we have when we are talking about the fold mountains. So let's look at an illustration of what we've been saying all this while. So the first is just a simple fold. You know, it's the limbs of the anticline and the syncline, they all have the same degree of slope. Then if you look at this fold, which is the asymmetrical fold, you discover that at this point you see that the slope of one limb, you know, of this anticline is greater than the other limb. Then here we have the overfold. In the overfold, the strata in one limb, you know, has been tilted, you know, as you can see here, has been tilted, you know, beyond what it's supposed to be, like beyond the vertical, and you know the other has been reversed. So you have the older strata of rock lying right on the on the younger or smaller strata of rock. Then for the overthrust, as you can see, the limb is tilted further, you know, when you compare it with the overfold. So that's why it's called an overthrust fold. And you see that it's tilted in such a way that the rock strata is no longer continuous. And at the end of the day, we end up having what we call a fault. Especially as you see somewhere around here that we have a fault in this region, or a point of weakness found in this region. So what are the features or the characteristics of fold mountain, the things that we can see to help us identify a fold mountain? Now, the first one is that the fold mountains are actually upland areas, you know, with a very, you know, high range of relief, ranging from 600 meters and above. And they are actually caused by the Earth's movement. They are caused by horizontal forces within the Earth crust, and they are as a result of stresses that, you know, that are built up in the crust. And also, the next characteristics or feature we should know is that fold mountains are mainly or majorly caused by by compressional forces, because without these compressional forces, there will be no form of fold or wrinkling of the rocks. And also, fold mountains, they have anticlines and synclines, and they also have steep slopes, and their valleys are usually very deep. Also, they have different types of fold. You know, as we've mentioned, we've seen the simple fold, the overfold, the overthrust fold, and the recumbent fold. And you can as well find faults or lines of weakness when you see a fold mountain, meaning that they are characterized with with cracks and faults. So these are the characteristics of fold mountains. So examples of fold mountains, we have different examples of fold mountains in the world. Now, the first example of fold mountain we have here is the Rocky Mountain in the United States of America. In Africa, in Morocco to be precise, we have the Atlas Mountain, the Himalayan mountain in Asia, which contains Mountain Everest, is also an example of a fold mountain. The Andes Mountain in the southern part of America is a fold mountain, and the Alps Mountain in Europe is also a fold mountain. So this is a typical example of what the Atlas Mountain looks like in Tibet, somewhere in Morocco. And these are other examples of fold mountains. So let's look at the second type of mountain, called a block mountain. A block mountain, otherwise known as a horst, is actually an upland area that is bounded by faults with the surrounding land. So if you look at a block mountain, they are actually caused by faulting, and in places where we have block mountain, we have series of upwards and downwards movement of these rocks that have been, shifted as a result of faulting. Now, when we say fault, we're actually talking about a fracture or a crack along a line of weakness in a rock. Now, this area of weaknesses, they actually move in relation to one another. Okay, now this is what I mean. If this is a rock and we have a line of weakness here and we have a line of weakness here, now what happens is that this line of weakness will cause the segmented rock to slide over one another. And when this happens, you will discover that we are going to have what? A block mountain and a rift what? A rift valley. So let's look at how a block mountain is formed. Now, assuming this is a plain surface initially, and then we have series of faults, or we have lines of weakness, that develops within the Earth's crust. As you can see here, these are faults or weaknesses here and here. Now, these lines of weaknesses or faults will actually cause the land to either be elevated or to be what? To be depressed down. Now, the elevation of a parallel rock, will lead to the formation of a block mountain. Why the reverse, which is a depression, will cause what? The formation of a rift what? Valley. A block mountain is otherwise known as a host, and a rift valley is otherwise known as a graben. So as you can see here, we have a host and what? And a graben. So this is what? This is a fault. So basically what we can pick is that block mountains are actually caused by what we call faulting of what? Of rocks. So faulting brings about the formation of block mountains and rift valley. So as you can see here, this is just the parallel fault or line of weakness, and a downward depression of the other layers of rock will give rise to what? Rise to the formation of a block mountain in between. Then an upward elevation of rocks on the sides will give rise to the formation of a rift valley, which is right here on the diagram. So let's look at examples of block mountains. Now, we have different examples of block mountains in the world, but popular examples of block mountain include the mountain we have in France, which is called the Vosges Mountain. Then in Germany, we have the Hornstruck Mountain and the Black Forest Mountain. So these are popular examples of what? Of the block mountains we have in the world. Then when we talk about the Rift Valley, which we otherwise known as the Graben, we have the Rift Valley in the eastern part of Africa, which is one of the longest river we have in Africa. Possibly that is River Nile rolling down the east. So we have the East Africa Rift Valley, and it has a distance or a length of 4,500 kilometers. Then we also have the Rhine Valley and the Jordan Valley and the Dead Sea. So these are examples of rift valleys we have in the world. Then what are the characteristics or the features of block mountain? Number one, they're actually caused by the movement, of the earth, but not compressional forces, and they are caused basically by tensional forces, and vertical and horizontal forces that compress the earth crust. So the key difference between the block mountain and the fold mountain is that for the fold mountain, the compressional force is actually in a horizontal direction, and there is no faulting. But for the block mountain, the tensional and compressional forces are basically in the upward and downward movement, and they are supported by the presence of faults. And also, block mountains have a flat top, and they are usually what? Steep on the sides, and they are majorly caused by what? By the action of faulting. Then for Rift Valley, which is the reverse of block mountains, they are actually caused by earth movement. They are still formed by compressional forces and upward and downward tensional forces too, and they are usually flat, you know, just the same way the block mountains are. They have steep sides, and they are linked with what? With faults. And places where we have the Rift Valley may as well contain lakes around there. So let's look at the next type of mountain, which is called the volcanic what? Mountain. Mountains that are actually formed from the ejection and accumulation of molten magma and other materials from the magma chamber are actually called volcanic mountains. And we can as well refer to volcanic mountains as mountains of accumulation. So when we have ejection of lava from the lava vents, and it accumulates on the surface along with ash, cinder, and other volcanic materials. Now, the formation of the highland caused by this accumulation is what we call what? A volcanic what? Mountain. And they are literally formed when we have this magma solidifying on what? On the earth's surface. So over a long period of time, this accumulation will lead to a very what? Elevated landform, which we can now call what? A volcanic mountain. So we look at an illustration of what a volcanic mountain actually looks like. As you can see here, this is a typical example of a volcanic mountain, and over time we have what? Series of molten lava or magma solidifying and accumulating on what? On the surface of the rock. Here we have the magma chamber, where we have the ejection of magma through the magma vent down to what? The surface in form of what? In form of lava and in form of volcanic bombs, ash, and cinders. And when they solidify, the resulting shape will be referred to as a volcanic what? Mountain. So what are the features or characteristics of volcanic mountain? They are formed from molten magma. They have steep slopes by the sides, and the materials that are being ejected from the magma chamber are solid, liquid, and gaseous in nature. And also, most volcanic mountains, they either have the shape of a cone or the shape of a lava dome. And they actually take their shape based on the amount and type of magma that is being erupted from what? From the magma chamber. And the liquid material that comes out from the chamber is called the lava, and they are also referred to as mountains of accumulation. So examples of volcanic mountains we have in the world. One popular example is Mountain Kilimanjaro in Kenya. Then we have Mountain Elgon. We also have Mountain Kenya too in Kenya, and we have Mountain Rwenzori, all in what? All in the eastern part of what? Of Africa. Then if you go to Asia, we have Mountain Mayon in the Philippines, and then in the central part of Africa, we have Mountain Cameroon. As you can see, this is an example of a volcanic mountain, and this is Mountain Cameroon to be precise, and Mountain Kilimanjaro. So they are basically the examples, or they are basically the mountains that are formed over time as a result of what? Magma ejection or volcanicity. So the next type of mountain is called the residual mountain. And when we say residue or residual, we're actually talking about remnant or something that is left over after a long period of time. So A residual mountain is actually a mountain that is derived when an existing, or let's say already existing mountain, has been affected by agents of denudation. Now, that's to say that we can actually get or derive a residual mountain from a block mountain or a fold mountain. So when a block mountain or a fold mountain has been affected by agents of denudation like running water, like wind or ice, for a very long period of time, now the resulting, the mountain that results from this action is what we call a residual mountain. And we can as well call residual mountains mountains of denudation. So we can have a very big block mountain, and after a period of 100 to let's say 300 years, after a series of erosion, weathering, we end up having a leftover or a residual type of mountain. So let's look at how the residual mountains are formed. They are actually formed when these running water or wind or ice, acts on the already existing mountain or the ancient mountain. So what is left is seen as as a residual mountain. And also with time, these residual mountains can evolve, from plateaus and dissected plateaus, to be precise. So when we have a dissected plateau that is either dissected by a river or a running stream, they can as well lead to the formation of residual mountains. And in arid regions, these residual mountains are actually referred to as in-sill-beg. So this is how a residual mountain is formed. As you can see here, we have the original surface of the mountain up here. Then after a series of downcutting by the erosive action of the river, we'll have a depression down here, and we'll have a slope down here. Apart from the action of water, we also have the action of wind and the action of ice, giving rise to the formation of a residual mountain. So the downcutting of this river or this glacier or wind is what will definitely lead towards a mountain of residue, as we have here in this diagram. So what are the features or characteristics of residual mountain? Number one, they are formed from already existing mountains or ancient mountains. They are either mountains or plateaus or hills, and most times we can still call them in-sill-beg. They have different heights and different sizes, and it's actually dependent on the level of denudation that has acted on that mountain. And they have irregular shapes or irregular surfaces with a steep sides, and they always evolve from the action of denudation. So these are the features of mountains of denudation. And we have examples of residual mountains in Nigeria and in the world. One popular example of residual mountain we have is the Idanre Hills in Ondo State. Then we also have the Ado Rocks in Oyo State. And somewhere in Europe, we have the Highlands of Scotland and the Scandinavia. These are some examples of residual mountains. And also in India, there is a popular plateau or in-sill-beg which is called the Deccan Plateau. The Deccan Plateau is also an example of a residual mountain, though most times it looks like a plateau. We're going to look at the key difference between a mountain and a plateau in the next lesson. So what are the importance of mountain? Now, why is mountain relevant to human? Now, the first one is that mountains are actually sources of several minerals, such as petroleum, gold, copper, tin, columbite, and many others. This is due to the fact that mountains that are actually, caused by, you know, action of volcanism, they tend to contain very precious minerals that we need. And if mountains can also provide fertile soils for us that we can use for cultivation of crops, and they can serve as a form of security for humans when they are experiencing a war, meaning that you can definitely hide, in a mountainous region from your enemies. And also, mountains are sources of what? Of rivers and springs. Most rivers, they take their source from what? From the mountains or the plateaus. So rivers take their rise from these mountains. And as a result of that, we can as well use what? These mountains to what? To generate hydroelectric power. Then in terms of tourism, mountains are actually a very nice place we can what? We can visit, or we can, tour. Example of this is the Idanre Hills in Ondo State. People go there, almost every week for, for tourism, just for sightseeing and for pleasure. And mountains help to modify climate, because the higher you go, the cooler it becomes. So mountainous regions are actually what? Very cool. And as a result of that, we'll have what? A relief climate in such a particular place. And mountains can serve as boundaries between one region or the other, or between one country or the other. And in places where we have mountains, we have nomadic men, or the herdsmen, actually practicing what we call transhumance. Transhumance is simply the movement of cattle or livestock up and down the hills in different seasons in search of pasture. And mountainous regions, we actually have some mountainous regions where there are what? There are forests and, big examples of hardwoods that can be used for lumbering. So some mountainous regions can favor what? Lumbering, and give us some types of what? Forest resource that we can use for our daily needs. So what are the disadvantages of mountains? Number one, some mountains, they are actually poor when it comes to the type of soil they have. And as a result of that, some of these mountains cannot support agriculture. Some mountains actually hinder what? Communication network, such as road network, railway network, airport network, and even telecommunication network too. Mountains also occupy large areas of land that human beings are supposed to settle or live on. And also, the steep slopes of a mountain will lead to soil erosion in the surrounding low lands. And also, mountains occupy a very large portion of land that we can as well use for what? For agriculture, we can use for our commercial activities, we can use for transportation and settlement. So let's look at some questions on mountains from the Examguide SSCE app. So we go to 2015 SSCE, and we look at theory 2. So let's head right to theory 2, and we take theory 2 number 5. Okay, number 5 says list any 3 types of mountains. So we have the volcanic mountains, we have the residual mountains, we have the block mountains, and we have the fold mountains. Now the next question says, in what 4 ways are mountains important to man? Now, as we've seen in the lesson that we've done, we've seen that mountains, they act as a form of protection in time of what? In time of war, as a means of defense. Then mountains actually provide a relief type of climate. Mountains are actually a good place for tourism, and mountains provide us with precious minerals that we can use for our various day-to-day activities or production. So these are some of the relevance of mountains to man. And also, outline 2 problems caused by mountains. Now, the first problem caused by mountains is that mountains act as a barrier to communication. They affect the construction of roads, railways, and even the telecommunication networks. And also, mountains occupy large areas of land that can be used for either agriculture or for human settlement. Thank you for participating in today's class. You can practice more questions using the Examguide app. The app scores and gives a detailed explanation of all the questions at the end of your practice test. You can learn a particular topic of interest with different modes like study mode, mock mode, and practice mode. It also has other features that make learning fun. It's a must-have for all serious students. Download from www.examguide.com if you don't have it yet. See you in the next class. Don't forget to subscribe to our channel, hit the notification bell, and share the videos to people that will benefit from it. Bye.